Hi, and welcome to today's video. Here we will be exploring two essential regression techniques in data science and machine learning: logistic regression and positional regression. Whether you are predicting binary outcomes or modeling count data, these methods have you covered. Let's dive in. Our first subtopic is understanding logistic regression. Logistic regression is a powerful statistical method used to predict the probability of a binary outcome, like predicting whether a customer will be purchasing or whether a loan will be default. Instead of predicting a value, logistic regression modeling models the probability of an event occurring. So, how does it works? The logistic regression algorithm. To map this probability, we use a psi-mod function which transforms the output of linear equation into a value between 0 and 1. This makes it perfect for modeling probabilities. Think of it as a curve where the probability of an event increases as the independent variables change. It never exceeds 1 or drops below 0. Minimum likelihood estimation. Next up is minimum likelihood estimation (MLE). This is the method we use to train the logistic regression model. The goal The goal is to find the parameters that maximize the likelihood of observing the actual outcomes in our dataset. MLE helps find the best fit line that accurately predict our target variable. Next in we have preparation data for logistic regression. Before we start modeling, we need to ensure our data is clean and ready. First, clean our data by removing missing values, outliers, or any inconsistent information. Feature engineering and data splitting. Next, we perform in feature engineering. This could mean transforming or creating new features and improve the performance of model. Finally, finally, split your data into training and testing sets. This helps evaluating your model's performance and unseen data. Next in we have implementing logistic regression in Python. Now let's implement logistic regression in Python. First, import the necessary libraries for machine learning. We use sci kit learn. Then we create the logistic regression model and train it using our dataset. Once the model is trained, it is used to predict probabilities or class labels for new data. Next in we have evaluating model performance. After training, we need to evaluate how well the model is performing. We need to look at the key metrics like accuracy, precision, recall, and the F1 score. These all the model performance techniques are covered in our videos. Videos. Accuracy measures the percentage of correctness classification instance, while precision focus on how many of the predicted positive instances are actually positive. Recall looks at how many actual positives were correctly predicted, and F1 score balance precision and recall for a more holistic performance measures. Next in we have position regression, modeling count data. Switching gears now to position regression, a method used to model count data like number of website visits or the number of trades in a financial market. Position regression is idea for data that involves count of events occurring in a fixed time or space. Assumption and application of position regression. Position regression assumes that the data flows a position distribution where the mean and the variance are equal. This is useful in many areas from healthcare to marketing. Next in we have implementing position regression in Python. To implement position regression in Python, We use stat models library. Import libraries. Import necessary libraries like stats models for static modeling. Load data. Data Load the data sets containing count data into Panda data frame or NumPy array. Create and train model. Use position family from stat models to create the and train a position and regression model. Make predictions. Use the train model to predict the expected count of new observations. Next in we have interpreting position regression result. When interpreting the results, we focus on the regression coefficients, which shows how the predictor variables affect the count variable. Coefficients with p-values. Also, look at the p-values to access statistical significance and evaluate the goodness of fit using metrics like AIC and BIC. Goodness of fit. Evaluate the model's goodness to fit using metrics like the AIS or BIC to compare different models. Finally, the word for conclusion. In today's video, we covered the basic of logistic regression and positional regression, two powerful tools for analysis binary outcomes and count data. To implement these models, remember the importance of clean data, proper feature engineering, and evaluation metrics. Thank you for watching and see you in the next video.